Welcome to another Greenway Engineering video tutorial. This video describes the process of shock disinfecting a potable water well. Shock disinfection is generally performed on new water wells or if a bacteriological analysis reveals the presence of coliform bacteria. First, gather the materials and information needed to perform the disinfection. A clean 5-gallon bucket, preferably polyethylene, as chlorine is corrosive to metals. A length of garden hose long enough to run from an outdoor faucet to the wellhead. Any household bleach with a strength of 5.25 to 6% chlorine. Make sure the bleach is unscented and has no detergents or dyes. Investigate the well cap to determine the types of tools required to remove the well cap. A copy of the well driller's report is available. From the report, determine the well's drilled depth and the depth to the static water level. If this information is not available, contact your local health department and determine if a copy is available from their office. First, rinse the 5-gallon bucket with tap water from the hose. Remove the fasteners from the well cap and lift the cap off and to the side of the wellhead. Remove and store any loose bolts, washers, and fasteners to prevent them from falling into the well. To prepare the bleach solution, first determine the amount of bleach needed by taking the water depth and the well depth from the driller's report and applying it to the formula. Well depth minus water level divided by 100 and multiplied by 1.5. This formula applies to a 6-inch cased well. Add the calculated amount of bleach to the 5-gallon bucket and fill the remainder of the bucket with tap water from the hose. After preparing the bleach solution, pour the contents into the well casing, avoiding any contact of the bleach solution with any wiring connections, splices, or wire nuts. Chlorine bleach solution is very corrosive and will quickly corrode metal objects. Rinse the bucket with tap water to remove remaining chlorine and pour into the casing. Rinse the inside of the well casing by swirling the garden hose to ensure bleach is rinsed down and into the water well. Place the hose into the well casing such that the hose will remain in the casing. Continue recirculating the water until a chlorine odor is present in the water coming through the garden hose. After chlorine odor is detected at the garden hose, distribute the chlorinated water into the household plumbing by running water at each of the faucets in the house. Bathroom sinks, showers, kitchen sink, and any faucets or hose bibs used in the home. Stop running water at each faucet once chlorine odor is detected. Allow the water to stand in the household plumbing for at least 8 hours, preferably overnight. If possible, allow the chlorinated water to remain in the piping for 24 hours. Note: do not allow the chlorinated water to run after chlorine is detected. Chlorine can have adverse effects on your drain field system. After the 8 to 24 hour disinfecting time, attach a garden hose to an outside faucet. Place the discharge end of the hose in an area away from any drain field area and away from garden vegetation and shrubbery. Continue running the water from the well until there is no chlorine odor coming from the hose. After flushing the system from the outside faucet and hose, flush the chlorinated water from the plumbing by running the faucets until free from chlorine odor. In the event that you are unable to detect the odor of chlorine, DPD test packets are available from our laboratory that will detect low to high range chlorine concentrations. The lab can provide the packets in pre-marked test bottles to ensure adequate disinfection is accomplished and adequate flushing is achieved. The video below shows the reaction of DPD in highly chlorinated water. To confirm that the potable well has been effectively disinfected, a sample should be collected and delivered to Greenway Laboratory for a presence-absence analysis for Total Coliform and E.coli. Please contact the laboratory to get information for obtaining the coliform sampling kit. A video explaining the full process for sampling for bacteriological analysis can be viewed by clicking the link below. Thank you for viewing another Greenway Engineering tutorial.